in DFA we have seen a problem where the second symbol from LHS is A, which means I don't care what is the first symbol, it can be A or B, but the second symbol has to be A, and then there can be anything else, right? There can be anything following it. We have seen that kind of problem, and the DFA has first symbol can be anything and the second symbol should always be A, then I am going to accept it, and if the second symbol is B, I am going to reject it, right? So even though this is the DFA, how could the NFA look like? NFA will look something like this. First symbol can be anything, second symbol has to be DA, and then I am going to accept it. So this is the DFA and this is the NFA. Only difference is that whatever is there in the DFA, the dead state, that we are not going to have in NFA. This is the DFA and this is the NFA. What if the question is second symbol from RHS is A? The second symbol from RHS is A is a bit complicated in order to construct directly a DFA. So let me construct an NFA and then convert it to DFA. Okay, so let me construct an NFA first. So now the question is this. Let's change the question. We have already seen for LHS, second symbol from LHS is A. Now I am going to see what happens if second symbol from RHS is A. First of all, I am going to construct an NFA for it, because constructing NFA is always easy. So second symbol from RHS is A. Let me write the language. So last symbol can be anything, it can be A or B, but the second last symbol has to be A from the RHS, okay? And last symbol can be A or B, but the second last symbol has to be A. And last symbol can be A or B, second last symbol has to be A, and then it can contain A or B. And last symbol can be A or B, second last symbol has to be A, and then it can contain A, so on. This is the language. For this language, NFA will look like this. I don't care whatever I see in the beginning. First symbol from RHS has to be, let us say this is the second symbol. Second symbol from RHS has to be A, followed by A or B. I am going to accept it. It is as simple as that. Initially I can see anything, which is nothing but initially I can see anything, and then it has to be A, and then it can be either A or B, which means sigma star AA, which means the second symbol is A, or initially it can be anything and then sigma star AB. So this is simply the NFA, and constructing it is very easy. And now if we have to construct DFA directly for such a question, it needs lot of analysis, and we are not going to I mean, you could do it, but then I am not going to do it. Let us construct this or convert this to, let us convert this to DFA. Now first let me draw state transition table for NFA itself. Capital A, capital B, capital C. A is the start state, C is the final state. Inputs are A and B, and capital A on small a is going to A as well as B. A as well as B. See this, capital A on small a is going to A as well as B, and capital A on small b is going to capital A itself, and capital B on small a is going to capital C, and capital B on small b is going to capital C. And what about C? C doesn't have any moves. Once you reach C, we are going to accept everything, and if I see anything, I am not going to do anything, so it is simply 5. This is the state transition table for NFA. Now let's convert it to state transition table for DFA. So now state transition table for DFA. So we are going to follow the subset construction method, which we have seen already. First step is take only the initial state, which is capital A, and then write the transitions. capital A on seeing small a is going to AB, which are two states, but then I cannot write AB, which are two states in DFA, because in DFA we are always interested in one state, or we should always write one state. Therefore, I am going to combine A and B and write it as AB, and here I am going to write it as A itself. I'll write all these states like this. Every state is single state and it is not a set of two states. Now for capital A, see, now what are the states reachable? AB as well as A. For capital A, I have already given the row, but I didn't give the row for AB. Therefore, I'll take AB. Now just think about it. I'm taking AB because AB is the only state for which I didn't give any transition. That is why I'm taking AB. Now after taking AB, I have to draw the transitions here or write the transitions here. So if you have two states here, just go to this and take the two states. What are the two states? A and B. These two states. Now you try to union these two rows. If I union these two, what is the result? A, B and C. Therefore, I am going to write A, B and C. It is very important that you observe how I am writing A, B, C. See, whenever I have A, B here, AB, then I'll go to the actual DFA, NFA, and then take two rows corresponding to A and B, and then I'm going to union those two rows. That is how I got ABC here. And what should I write under B? Go to A and B and then union these two rows. If I union these two rows, I'm going to get AC. Why AC? Because A and C are here. Therefore, I'm writing it as AC. Now just think about it. What are the states reachable? AB, and for that AB I have given the row, and for A I have given the row, but then I didn't give any row about ABC or AC. Let me take AC first. You can go in any way. Let me take AC first. Okay. Now in order to fill out this row, go to the NFA and then find out A and C rows and union them. If I union this one and this one, if I apply union to C row and A row, I get AB. Therefore, I am going to write it as AB. And if I union A row and C row under B column, I am going to get A. AB is already seen. For AB I have already given the transition, and A I have already given the row. Therefore, I am not going to touch them. Only untouched one is ABC. Therefore, I am going to take A, B, C. Fine. So in order to find out the transition for ABC, go to the NFA table and then take the union of A, B and C rows. Therefore, I get A, B, C and AC. Now if you look at this, already AC has already been discussed and ABC has already been discussed. Therefore, this is the final transition state for DFA. Now let us see, or let us analyze what this DFA is exactly doing. DFA, see, in order to analyze, I cannot analyze this way. I mean, if you can analyze it, it is okay, but then I am more used to analysis using the state transition diagram. So let me take state transition diagram and see what is happening. How many states are there? 4 states: A, AB, AC, ABC. So A on small a is going to AB, and B is going to, A is the starting state, and then AB on small a is going to ABC, AB on small a is going to ABC, and AB on small b is going to AC, AB on small b is going to AC, and AC on small a is going to AB, and AC on small b is going to A, and AC on small b is going to A. ABC on small a is going to ABC, and ABC on small b is going to AC. And if you look at it, what is the final state here? See, initial state is always going to be the initial state here, and here the final state is C. Therefore, final states are any state which is containing C. Any state which is containing C is the final state. Any state which is containing C is final state. Now let's try to analyze what has exactly happened here. Let us just try to analyze what happened here. See, first point is capital A on any number of B's, it is simply going to accept it, and whenever it sees an A, it is assuming that it is the second loss symbol and it is going to AB. Capital A, any number of B's, it is going to stay in capital A itself, and on seeing a small a, it is going to AB, thinking that it is the second loss symbol. Now, either the next symbol is A or the next symbol is B. If this is the entire string, I am going to accept it. If this is the entire string, any number of B's in the beginning, and the second loss symbol is A, and the loss symbol can be A or B. Any number of B's in the beginning, second loss symbol is A, and the loss symbol can be A or B. I am going to accept that. I am going to accept that, right? But there are many cases to consider here. First case is, so let us assume that you have seen A and then A and you have reached this one. So any number of B's you have seen, and finally AA you have seen, which means second loss symbol is A, and you have reached ABC. Now if you are in the state ABC, and if you have seen any number of A's, still the second loss symbol is going to be A. See, any number of A's, still the second loss symbol is going to be A, therefore it is going to accept everything. Now let us say you have reached ABC by seeing many number of B's followed by a followed by a, and what if you see a B? Even if I see a B, the second loss symbol is going to be small a itself. Therefore, even if I see a B, the second loss symbol is going to be small a, I have to still accept it. So even if I see a B, I am going to accept it, but I am going to remember that the previous symbol I have seen is small b. Now after that, if I see a then I have to wait for either A or B. Therefore, after that, if I see a I'll go here and I'll wait for either A or B. If I see a B, the second loss symbol is going to be again A. Therefore, if I see a B, the second loss symbol, let us say this one. If I see a B, the second loss symbol is B, and therefore I have to again go back and wait for an A and followed by A or B. Therefore I am again going to go back and wait for an A or B. So it is very complex to directly construct this diagram with this kind of analysis. Therefore the easier way or the best way is to start out with the NFA, convert it to transition table, and then convert it to DFA, and then you can directly give the DFA. Okay. So this is the DFA for this problem.